Okay, so today we're diving into something really cool called EvoSkill. And the big idea here is a system where AI agents aren't just, solving problems, they're actually teaching themselves how to get better. They automatically discover and refine their own skills over time.
But that brings up the big question, right? How can an AI possibly learn a brand new skill if there's no human teacher guiding it? How does it go from being a generalist to a true specialist, all on its own?
Well, the secret sauce, it turns out, is teamwork. The EvoSkill framework isn't built around one single super smart AI. Instead, it's a dedicated team of 3 different agents, and they're locked in a cycle where they learn from every single mistake. Now, to really get why this is such a game changer, you have to look at where we are right now. We have these incredibly powerful general AI agents, but you give them a really specialized, tricky problem, and they just hit a wall. They don't have that deep, focused expertise to get the job done reliably. And that's because this approach is a total shift in how we think about improving AI. See, the old way was to go in and tweak the low-level stuff, the prompts, the code. But those fixes are brittle. They're specific to that one task, and they break easily. EvoSkill works on a much higher level. It creates actual, reusable skills. Think of them like tools in a toolbox that an AI can use for any job, not just one.
All right, so let's meet this self-improving AI team. The whole EvoSkill system really comes down to these 3 agents working together, and each one has a very, very specific job. First up, you've got the Executor. This is the doer. It's on the front lines, taking its skill set and trying to solve a problem. Now, when it messes up, and it's going to mess up, that's when the proposer, our analyst, wakes up. Its job is to look at the failure and figure out exactly what went wrong. Then it hands that analysis off to the skill builder, the engineer, who takes that insight and actually builds a brand new skill or maybe just tunes up an old one to make sure that mistake doesn't happen again.
And this right here is the heart of the whole system. It's not a one-and-done fix. It's a constant loop where every failure isn't a problem, it's an opportunity. It's a lesson.
Now, I know this diagram might look a little intense at first glance, but it really just shows that whole process in motion. It's this elegant cycle. An agent tries something, its failures get collected, a new skill gets proposed and then built, and finally, that new skill has to prove itself. So let's just walk through that loop one step at a time.
So it all kicks off with the executor trying to solve a bunch of problems from a training set. Anything that doesn't hit the mark gets flagged as a failure. That's the cue for the proposer to jump in, analyze what went wrong, and suggest a fix. Maybe a whole new skill is needed, or maybe just an update to an existing one. The skill builder then takes that idea and makes it real, a new skill with instructions and code. But here's the most important part. That new skill is immediately tested on problems it has never seen before. It has to prove its worth.
Let's make this real with an example. In one test, the agent was trying to pull data from these super dense US Treasury tables, and it kept failing. It was grabbing numbers from the wrong cells or mixing up different metrics. So the executor failed, and the proposer stepped in to do its analysis.
And boom, this is what the skill builder created. A totally new skill it called data extraction verification. It's basically a super strict checklist for how to pull numbers from a table, and it was designed specifically to avoid all the mistakes the proposer had just pointed out. Just like that, the agent has a new, specialized tool in its toolbox.
But, just making a new skill isn't quite enough. How does the system make sure that new skill is actually an improvement and not just noise? Well, this is where a really clever quality control system kicks in.
The system keeps this elite list of its absolute best performing versions of itself. It's called a Pareto frontier. You could think of it like the varsity team of AI agents. Only the absolute best of the best get to be on this list.
So, for a new skill to make the cut, the agent armed with that skill has to compete. It's tested on a secret set of problems it's never seen, and if it scores higher than the worst performing member currently on that varsity team, it gets a spot, and the weakest one gets kicked off. It's this ruthless survival of the fittest process that guarantees only the most useful skills stick around.
So, does it actually work? Oh yeah, it works. On that tough Office AQ benchmark with the financial data, EvoSkill got a 7.3% boost in accuracy. And on another benchmark called SEAL QA, which involves noisy, messy web searches, it saw a massive 12.1% improvement. I mean, these aren't just tiny little tweaks, this is a serious leap in performance. And that brings us to what I think is the most mind-blowing part of this whole thing. The real magic isn't just about getting better at one specific task, it's about creating skills that are so fundamental, so universal, that they could be used for totally different problems.
This is the ultimate test. Can you take a skill that was learned in one very specific context, give it to an agent facing a completely different challenge, and have it just work right out of the box with no changes whatsoever? This is called zero-shot transfer, and it's a huge deal.
So here's what the researchers did. They took a skill that was evolved on that messy web search task, COQA. The skill was basically a protocol for being really persistent and double-checking your sources. They took this search persistence protocol skill and just handed it to a different agent working on an entirely separate task, the browse comp benchmark.
The result? An instant 5.3% jump in accuracy on the new task. It didn't need any fine-tuning. The skill just worked because it captured something truly fundamental about how to find information carefully. And this really proves the whole point of the research. When you optimize on the skill level, not the code level, you create these abilities that can travel. They go way beyond the original problem the AI was trained to solve.
So what's the big takeaway from all of this? The really crucial point is that we're watching a shift away from building one-off solutions. By evolving skills, AI agents can build up a whole library of reusable general-purpose abilities, a toolbox that gets bigger and better over time, ready for any problem they might face in the future.
And that kind of leaves us with a pretty fascinating question to think about. If AIs can create, refine, and even share these skills on their own, what happens when they start pooling that knowledge? What's the first huge world-changing problem they're going to solve together?